Alright, so in today's particular C course, we're going to be combining a few of the things that we've been looking at previously, and looking at how we can build a full-featured application with them. So we've been looking at a bunch of different features of the C language, and so now we're going to use some of the libraries that are available to us on Linux for network programming. And we're basically going to access a very low-level API in order to do some network programming, and we're going to do what's known as socket programming. And socket programming is basically the low-level interface that everything that needs to do network communications on your system needs to use. Sockets are used to connect to the internet. Processes have sockets in order to make network connections, make requests to servers, and get responses. So we're going to write a basic server that'll simply just print out to the screen whatever gets sent to it from a client application. So in order to do that, we're going to need to dive into sockets a little bit and what the flow of the API that we're going to use is going to look like. So let's take a quick look at a small representation of all the functions that we're going to need to use and kind of the basics of how the sockets are going to be set up and what they need to do. So in order to set up a socket server, we're going to need to use a few of these functions that are going to be in the network libraries that we're going to end up including in this application. So there's sort of four basic steps that we're going to need to implement in order to have a fully functioning socket server that can respond to network requests. So first we're going to create a socket, and the socket is basically sort of the entry point for where we'll do our connections to the internet. Sockets have types, and sockets use particular protocols. So in our case, we're going to be setting up a stream socket that uses the TCP protocol, which is the standard protocol that most of the applications that we generally use, such as web browsers, use to connect to the internet. TCP is used for HTTP, which is the protocol that we use to make requests to web servers to get web pages back. It's sort of a basic protocol that is used around the web for network communications. So when we create a socket, we're going to create a TCP socket, and that'll be the entry point for our communications. In order to set up the socket, we need to bind it, and that's the next function that we see here in this flow. Bind allows us to connect the socket that we have set up, prepared to do communications, with a port and basically an IP address on our system. So we're going to connect it to a local IP address, and an IP address is just a location on the network where we can find a resource. In this case, so we're going to connect our socket to the IP address of our own machine and to an open port on our machine, and basically that way it can be open to connections from other client applications. So other applications can find our server with a combination of the IP address and port. That basically tells the client application allows us to figure out how we can connect to our server, and we need a combination of those two pieces of information. After we bind our socket to a particular port, we have to then listen for connections, incoming connections. So this basically sets up our socket so that we wait for connections from a client, and after a client connects is when we do something with what we get from the client, or what the client, what data the client sends to our server. So when we listen for connections, we're ready to do the final step, which allows us to process what happens from the connection, and that's accept. And we will use the accept function to actually accept a particular connection from a client, and then from there we can do something particular, like read data from the client connection or write data to the client connection. And in a lot of cases you do both. In terms of the HTTP protocol, when you get a web page, you send a request to the server, and the server responds to you with what you've requested. So this is the basic control flow, these are the functions that we're going to need to use, and we'll take a look at what we call each of these with, and how we can set them up in order to create a small server that we can send some data to and get it printed out. So we're going to start by including the normal headers that we've been including in a lot of our applications, the standard I/O and the standard library headers. But then we're going to need a couple extra headers for the information that we're going to need for setting up sockets. So we're going to need the socket functions, some special socket types, and some predefined structures that are going to help us for working with the things that we're going to need to set up for a socket. So we can define our main function and then start including some of these other headers and take a quick look at what they are going to actually include. So we're going to need to use some headers from the sys folder, the first two being socket and types, and we can include them like this. This has a bunch of the definitions that we'll need for setting up a socket, and we'll get the types in the next include. And finally, one other header that will be from net-inet that'll define the structure that we'll need for setting up addresses. So that's basically all that we're going to need in order to set up our socket server. So in order to get started, we need to start with the first part in the flow. We're going to need to set up a socket. So there's a socket function that we can use to actually set up a socket, and we can assign a socket to an integer variable type, and our function call can basically look a little something like this. So we'll set up an integer variable to hold our actual socket information. And then we'll make a call to the socket function. So the socket function will take 3 arguments, and the first is going to be what's called the domain of the socket, and that's basically where the socket's going to operate. We're going to set up an internet socket, and that's basically how we create sockets that'll have internet connections. And so when we included the types, we have a built-in sort of constant defined for this that we can use like this. It'll be AF_INET, and that specifies that we're creating a socket on the internet domain. The next argument to socket is going to be the socket type. The socket type and protocol are sort of closely linked, and like we talked about earlier, we're going to be creating a TCP socket, or a stream socket in this case. That type is called sock_stream, and that's also predefined with the headers that we've included. So all we have to do is specify it like this. And then, since we'll be using the default protocol, TCP, we just specify 0 as the last argument, and that last argument has to do with the protocol. So the next thing that we're going to need to do in order to set up our socket server is specify where we're actually going to set up the socket server. We need to make the bind call, essentially. So in order to make the bind call, the bind function takes a structure that's basically a sock address struct, and it'll contain some information about our address, where we're going to put our socket, and what host and what port we're going to connect it to. So we can define a sort of instance of the structure in the same way that we've learned previously. The type in this case is struct sock_addr_in, and then we can call it whatever we want to. Just going to call it addr in this case. And then we need to define 3 key variables on this particular structure in order to send it off to our bind call to have it work properly. So first we need to set the family, and we can do that like this. This basically is going to be used to specify the general type of address that we're defining here. In that case, we're going to set this to also be AF_INET like we have for our socket. So then we need to define the actual network address of our particular socket. So we can do that like this. This is the variable name that we're going to need. It'll be synaddr.s_addr. And since we want this particular socket to be opened on our local machine, we have a special constant defined in our headers that allows us to set this socket up to any available network address on our local machine, and it'll look like this. And then finally, we need to set up the port. We can just pick any port number, preferably above 2000 on our computer, in order to have a port that we can bind this to, and we're going to need to remember that for the client connection. But we're going to need to call a function that makes sure that the bytes are actually stored in the appropriate order so we don't miscalculate what the number is that we're sending. This function is called h2ns. You can call it like this on whatever particular port number you want to bind to. And I'm going to use port 3001 for this. And then we can call the bind function. The first argument that we pass is our socket that we've set up. Then we pass the address structure that we've set up, but we need to cast it to a slightly different data type first. We're simply going to cast it to struct sock_addr without the _in. Basically just need to make sure that this structure is the right type when it goes into the bind function. That's what the cast is for. It'll change the type of the structure from sock_addrin to this type that we specified here. And we'll pass the address to this cast. And then finally, we're going to pass the size of the address in the last parameter. We can use the size of function to get that. So now, at this point, our socket will be bound to a particular address like we specified earlier in the code. So now what we need it to do is to listen in. And we can use the listen function like we talked about earlier. And all we have to do is pass the listen function a parameter that is the maximum amount of requests we can have pending at one point in time. We'll just use 5 in this particular case. And from there we can execute the final step in this code, which is accepting network connections. And so when we accept the network connection, that's when we'll actually be able to handle the connection from a client and do something with the data that they send us. So we're going to need 2 new variables for accepting our connection. First, one to hold the actual connection in the same way that we do the socket. So we'll create another integer. And then we'll need to create a variable to hold the data that we get from our client. We'll just call that our buffer. We'll set it to a size of 256 so we can hold a lot of characters in there, and we'll initialize this to 0. So we make sure it starts empty. So finally we can call the accept function. So the accept function will return something that we can pass to our connection variable and use that to get the information from what our client has sent. To accept, we pass the socket, And then here we could pass structures in order to capture the information of where our connection is coming from, but we don't really need that yet, so let's set both of these to null since we don't want to store these pieces of information for right now. That basically means that they won't be captured. From there, we can just read some information from our connection into our buffer, like this. We use a read function and specify the connection, the buffer, and how much data we want to read. At this point, our client will have connected, and the buffer should have the information that our client has sent to us, so let's just print it out to the screen in the same way that we would any other information, like we've been looking at, using printf. And that's it. That's all we need to do in order to set up a simple server. So now we can make this, and we'll look at a way that we can test it pretty easily without having to write another client application. So first, in order to get our server running, we can make that and run it the same way that we have been. So as soon as we run the application, we won't get any output. It will wait until it receives the connection to print it out to the screen. So what we can do is open a second terminal and run a command there called nc in order to access our server and send it some data. So first we'll start our server up, and it's waiting for a connection to accept. So then we'll open another terminal, and from there we'll run a command that lets us access the server. So our server is running, and we've opened another terminal that we can use. So from here, let's run the nc command like this. Nc takes, in the way that we'll use it, we will pass a host name, in this case our local machine, and a port number. And we'll use the port that we defined while we were writing this program. In that case, that was 3001. So we've been able to establish a connection to the server, and now the server is waiting for us to send it some data. So let's write a small message here. And then let's take a look back at the server window to see what happened. So as you can see, the information that we sent from the client application over there was sent to the server and printed out to the screen, and then the application exited, because after the accept is finished, our application was essentially set to return. So our application went through all of the steps necessary in order to set up the socket, bind it to the connection on our local machine with the port that we specified, and we were able to verify that with our client application. Listen for connections, as it did until we sent data to the server, and then accept a connection where we can read the information in our particular client's message and print it out to the screen. So in writing this application, we've been able to see that most of the techniques that we've already looked at within the C programming language can be used to implement a variety of different applications. We're basically using everything that we've looked at with structures, functions, and calls and data in order to implement a very simple server. From here we can kind of look at libraries and continue to get into more advanced types of applications, because we have a foundation and understanding of the basic things that we're going to need to be looking at when we work with C programming. So from here we could look at a little bit more high-level network protocols that we can implement, but this is just a start for the basic implementation of a socket server in C. So that's it.